go. The world today is rapidly and continuously developing. High-rise structures has already dominated our skylines, and industries have continuously provided us with the products that are essential to our day-to-day living. However, along with that development, there should be systems that ensures the protection of the health and safety of our workers, and most importantly, the communities living around it. A pleasant day to each and everyone. We are the peer group number 4. I am Bench Clark Nier, and together with me are Karinel Cane, Shelo Karangkarang, Kyle Van Excel Likop, and Shania Eve Shalana. And today, we will discuss on the Philippine Mechanical. The Philippine Mechanical Engineering Code consists of the basic principles used in the mechanical engineering field. It has 29 chapters intended for the different equipments, applications, as well as guidelines for hazard mitigation. Some of these chapters involves the general requirements, the ventilation air supply systems, smoke control systems, fire protection systems, as well as the standards used for this code. Unlike a handbook, the Philippine Mechanical Engineering Code is intended for the general public. Its language is patterned to such that anyone could easily understand this code, whether you are in the mechanical engineering field or outside the mechanical engineering field. Who are the typical users of this code? The code is often used by a building official, an engineering supplier, a government engineer, a consultant, and etc. And to better understand the Philippine Mechanical Engineering Code, we will take two examples of industrial disasters. First is the Bhopal disaster in 1984 at India, and second is the Grover Shoe Factory disaster in 1905 Massachusetts, USA.
Good day, this is Shania Eve Shalana. For the first case study, the Bhopal disaster, also referred to as the Bhopal gas tragedy, was a gas leak incident on the midnight of December 3, 1984, at the Union Carbide Corporation, Bhopal, India. It is considered among the world's worst industrial disasters. About 40 tons of the dangerous gas methyl isocyanate or MIC escaped from the plant. The gas drifted over the densely populated neighborhoods around the plant, killing over 3,000 people immediately and over 500,000 of people injured. The MIC stored in the E610 tank came in contact with water. A lot of heat was generated due to an exothermic chemical reaction after mixing of the two substances. It resulted in a burst of the safety valve of the tank due to the increase of pressure. According to the article of the New York Times, chemical experts, plant workers, company and former officials discussed the following irregularities of the Bhopal. At the Bhopal. First, according to the plant employees, that several months before the incident, the managers shut down the refrigeration unit that was designed to keep the MIC cool and inhibit chemical reaction. In connection to the Philippine Mechanical Engineering Code, it clearly violates the Chapter 8, Section 5, which is the refrigeration system. Cooling systems must not put to shut down because it is designed to keep cool the chemical or materials that are sensitive to wheat. Next, the washing operations proceeded despite failure to insert a slip line into the pipes to make sure that water did not back up into storage tanks. And the fact that one or two of bleeder valves at the bottom of the pipes where wash water should have come out were blocked. In connection to the PME code, clearly neglects the Chapter 11, which is the pipe rings. In sections 3.17, 6.17, 8.5, and 8.7 states that in order to operate satisfactorily, a safety valve must be mounted vertically. It should be directly on the vessel nozzle or on short connection fitting that provides direct and unobstructed flow between the vessel and the valve. Safety valves protecting pipe systems should of course be mounted in a similar manner. The device may never be installed on a fitting having a smaller inside diameter than the safety valve inlet connection.
Another irregularity found was the firewater spraying systems designed to deal with fires, cool down overheated equipment, or provide supplementary water neutralization of gases was operational, but the spray could not reach the top of the flare stack. This violated PME Code Chapter 9, Section 4.4a, adequate public water systems with hydrants suitably located for protection of the storage. This also violated Chapter 9, Section 1.2 of General Safety Requirements, which states that facility shall install, provide, incorporate, adapt, and maintain under operable and usable conditions the automatic fire protection devices, equipment, fire safety construction, and warning system. Another is plant operators failed to move some of the metal isocyanate in the problem tank to a spare tank as required because, they said, the spare was not empty as it should have been. Workers said it was a common practice to leave metal isocyanate in the spare tank, though standard procedures required that it be empty. This violated Chapter 1, Section 4.2. Annual inspection shall be made to see that A. Equipment as originally installed are still safe to operate for at least another year, and B. No change, addition, or alteration deviating from the original plan was made without prior permit from the proper government agency concerned. And the last one is instruments at the plant were unreliable. According to Shakil Qureshi, the methyl isocyanate supervisor on duty at that time of the accident. For that reason, he said he ignored the initial warning of the accident, a gauge indication that pressure in one of three methyl isocyanate storage tank had risen fivefold in an hour. With that, they neglected safety standards set in Chapter 27 of PME Code 2008, which is all about instrumentations. So this is the image before the incident. And this is the image after the incident.
So the next event that we will be looking into is the Grover Shoe Factory disaster. On March 20, 1905, in Brockton, Massachusetts, Grover Shoe Factory, 58 employees died and 150 people were injured during a boiler explosion. The Grover Shoe Factory is the largest boiler disaster ever recorded in American industrial industry. With spring weather coming, the operators of the Grover Shoe Factory decided to switch off their new high-pressure boiler. Installed just 2 years earlier, it needed maintenance after a hard winter of work, and that was the decision that touched off the 1905 Grover Shoe Factory disaster. It caused a disastrous chain of reaction. The explosion knocked over a water tower which smashed through the roof of the building and caused one end to collapse entirely, killing some workers and trapping others. The building burst into flames from the explosion and killed several others who were trapped inside. This event led to much more stringent safety laws as well as national code governing the operation and use of steam boilers in industrial settings. The impact of the disaster could have been minimized if they fixed some irregularities present in the factory at the time. So one of the safety standards that were neglected is when at least 2 barrels of naphtha were stored in a wooden shed directly behind the boiler house. This violates the PME code of the Chapter 7 on the pressure vessel and boiler on section 1.2, where it is stated that steam boilers should preferably be located in detached buildings of fire-resistant construction used for other purposes and situated not less than 3-meter distance from buildings not forming part of the factory, or in structures of fire-resisting materials, preferably stone or concrete walls, connected to or in close proximity to the other factory buildings. So, as we all know that naphtha is a flammable substance, the study said that without the naphtha explosions, the number of deaths would have been only about 1/4 of the actual. So, in relation to that, another irregularity um, regarding the naphtha is that the properties of it were not taken into consideration. Naphtha is a highly flammable liquid of hydrocarbon mixture, and according to the PME code of 9.2.2 under extra combustible materials, materials which either by themselves or in combination with their packaging are highly susceptible to ignition and will contribute to the intensity and rapid spread of fire. So that is why these substances should be stored and handled properly.
So to continue the discussion of the safety standards that were neglected by the Groover Shoe Factory, another thing is that their boiler, which covered nearly an acre of land, was built with lap joints. The design had a weakness. If a crack forms in the edge of the steel overlapped with the other piece of steel, the two plates can hide it from inspectors. Inspectors for the Hartford Boiler Insurance Company had very keen eyes for cracks. Each year, they found thousands of them and ordered repairs. But inspectors could not see between the two layers of a lap joint, and that's exactly where the oil boiler in Brockton showed its age. A crack in the steel, perhaps imperceptible when constructed, had slowly widened under years of strain. As the boiler heated and cooled, the crack widened. Gradually, the steel weakened until it gave way in a massive explosion. So, under the PME code, they violated Chapter 6.3.12, which is the lap joint, and a lap joint consists of two pieces of steel that overlap for several inches and are held together with steel rivets. Lastly, the integrated sprinkler system in the area. Barrels of naphtha were stored in a wooden shed directly behind the boiler house that was set on fire by the burning coals, and the naphtha exploded. But since they have employed outdated safety standards, the collapse of the building instantly disabled the sprinkler system in the building. And to connect this to the PME code, they violated Chapter 9.2.2, which is the sprinkler system. And a sprinkler system for fire protection purpose is an integrated system of one or more water supplies for fire use, underground and overhead piping designed in accordance with fire protection engineering standards. And this is the picture of the Grover Shoe Factory before the incident. And this is the picture pictures rather of the Glover Shoe factory after the incident.
And to wrap up our discussion on the Philippine Mechanical Engineering Code, I think that it is really important that we implement guidelines and standards that ensures the facilities that we construct or the equipments we install will not be easily damaged or it would not malfunction when in operation. This is for the ultimate purpose of protecting the lives and health of the workers as well as the surrounding communities. We should take the lesson from the two industrial disasters, the Bhopal disaster and the Grover Shoe Factory disaster, and uh, try not to do the mistakes that was done in those two incidents. We don't know the amount of damage that it would cause and the number of lives that may be put in casualty if uh, another disaster such as those two will happen again in our hands. And again, we are the peer group 4. That would be all for our discussion on the Philippine Mechanical Engineering Code. And I wish everyone a great day and thank you for listening.